Now let us see the different types of events. Now before we go into the details, it is important to note that the different terms in the probability are very much analogous to the corresponding terms in the set theory. So we will see that there are a lot of parallels and analogies between set theory and the probability. So let us see all the events one by one. First we have what is called as a simple or elementary event. Now it means that it has only one outcome out of the sample space. The next is compound event. Now compound event means it has more than one outcome from the original sample space. The third one is equally likely events. Now as the name suggests, equally likely events means the probabilities of those events are identical. Now remember that equally likely events does not necessarily mean that the events themselves are equal. That means let's take an example of, say, throwing a die, and suppose let us denote probability of some event E1, okay, where the event E1 is given as it's the event where an odd number appears on the die. So that means this event will consist of the different outcomes as 1, 3 and 5, because those are the only odd numbers that you can get after throwing a fair die. Now if I consider another event, say E2, where instead of odd numbers I say that even number, so that means event 2 is such that I am getting an even number when I throw a die. So naturally this will consist of the outcomes 2, 4 and 6. Alright. Now if we think of probabilities of these two events, you will find that each of the event E1 and E2 has the same probability, that is nothing but 1 by 2, because we know that each has half number of outcomes. So you see that both the events have same probability, therefore they are equally likely, but the events themselves are different. So this is to be kept in mind. Then the next type is impossible event. Now as the name suggests, impossible event is such that it's an event that will never occur. Okay, there is no chance that it will ever occur. So that means if an event is an impossible event, it means that its probability is nothing but equal to 0, right? So let's take as an example that if we ask the question, that is, what is the chance that we will get number 7 when we throw a die, right? We know that on a die we will never get a number 7, so therefore it is an impossible event. So that is, its probability is 0. This is one extreme. Now on the other extreme we have what is called as sure event. Now as the name suggests, sure means it is 100% going to occur, or in other words it's an event which always occurs no matter what. Now here let's take an example similar to the previous, that is, we throw a die, and if I define the event E such that a number between 1 and 6 is obtained, including both the numbers 1 and 6, and that number is a natural number. So we know that this event is always going to occur because we always are going to get some number, some natural number between 1 to 6. So therefore probability of such event will be equal to 1, because it consists of basically entire sample space. So therefore sure event has the probability as 1. Now next we have two very important definitions or types of events. Sixth one is we have exhaustive events. Now here exhaustive events are nothing but if you add up or merge all the events together, they will give you the sample space, right? So that is what we technically call as union of different events. So that means here the way we denote it is, as we will study later, it is a union of the event EI, where EI is a generic symbol, where I varies from 1 to n. That means I can have a value from 1 to n, that is I is just used as a counter. Okay? So therefore here we have union of EI where I varies from 1 to n. So that union, if that is equal to the sample space. Okay? So if this is equal to sample space, then we call all those events as exhaustive events. And lastly, we have what is called as mutually exclusive events. Now here also, suppose we consider a number of events, say E1, E2, E3 up to say En. Okay? And suppose we have all the possible pairs created from that set of events. That means say E1 and E2 or E2 and E3 or E1 and E3 and so on. So in general, let us consider some pair which we denote as EI and EJ. Okay. Now if this pair forms the pair such that there is no outcome common in both of the events, so they are called as disjoint sets in sets theory. Alright. So if this is the case, then we denote that EI intersection EJ is equal to a null set, because there is no element common in both of these events. Now if all the pairs are such that they have no element common among them, then together that entire set of events is called as mutually exclusive events, or they are also called as pairwise exclusive events. So these are the important types of events that we will be using in the sums related to probability.